right, so now we are going to be talking about solving by another algebraic method called elimination. This is section 4.3 in your book, which is what page? 159. All right, your book does not call it elimination. Your book calls it the addition method, okay? Be flexible with that. Some textbooks and teachers call it elimination. Some call it elimination with addition. Some call it elimination with multiplication and addition. Some call it just the addition method. It's all the same thing. There are two algebraic methods. One is substitution and one is elimination, aka addition method. Okay? What you're going to do is you're going to add the two equations together so that one of the variables will eliminate temporarily. We'll just stick with this right now. Okay. In order for two terms to eliminate, that would mean that they would have to add to be 0. Okay? Like there would be none of them left. What sorts of numbers add to be 0? Give me two numbers that add to be 0. So opposites, right? She said negative 2 and positive 2. If you add negative 2 and positive 2, you get 0, right? So by that same token, if you added negative 2x and positive 2x, you would get 0x. So the x's would be gone. Does everybody follow that thought process? So that's what we're doing. We're going to be looking for one of the variables, either the x's or the y's, to have the same coefficient on them but opposite signs. If they do not, we are going to use multiplication to make them match up like that. Same coefficient, opposite signs. Let's look at one. I would like to do one that's already in that form first, and I do not see one like that, so I may just have to make one up. So if I gave you 3x, now if I'm making this up, you know these answers are probably going to be not pretty, okay? Plus 7y equals 9. And then when I know that I'm going to use the elimination method, I keep my equations on top of each other so that I can add them straight down, okay? And I'm going to make this one be, let's say, 2x minus 7y equals 1. Okay? So I've been told to solve this system by elimination. Now, always in the back of your head, you should go, well, I'm going to find where these two lines would intersect each other if I were to graph them, but I'm not going to graph them. Do you see one of the variables have the same coefficient but opposite signs? The y's do, right? Which means that you can simply put a big giant plus sign and add the two equations together. Now you're eliminating one of the variables, in this case the y's, but you're only doing it temporarily. It doesn't go away forever. It's just a method to help you solve, okay? 3x plus 2x is 5x. Positive 7y and negative 7y is gone. 9 plus 1 is 10. Divide by 5 on both sides, and you get x equals 2. So you found the x. Now you're going to take that value and you're going to substitute it back into one of the original equations, whichever one looks the friendliest to you. It does not matter. They're a system. So I can put 2 in the first one or the second one, and I'm going to get the same y no matter what. I like to work with the one that doesn't have any negatives in it if that's an option. So I'm going to put it in the first one. So 3 times x, which is 2, plus 7y equals none. 3 times 2 is 6, plus 7y equals none. Subtract 6 from both sides. 7y equals 3. Divide by 7 on both sides of the equation, and y is the fraction 3/7. So your ordered pair solution here is 2, 3/7. This would be one of those you would not want to solve by graphing because you wouldn't be able to tell that it was 3/7. Your best guess would be that it was at a half probably because the point would be really close to a half where they intersected each other. Okay? That's your elimination method in the easiest problem I could probably think of to give you. We're going to move on to one that's a little more difficult. 3x equals 2y minus 5, and 2x plus y equals 6. Now, do you notice anything peculiar about one of these equations? What did you say? Okay. Do you notice the placement of the variables being odd? Do you see how this one has the x and the y added together on the left side of the equation, and this one just has the x sitting by itself? So you always want your equations to be lined up like this, which is called standard form. Okay? You want your equations to be in ax plus by equals c form if you are solving by elimination. So I want them in this form if I'm solving by elimination. If I was solving this by substitution, I would be pretty close to being where I would need to be, wouldn't I? I could just divide everything by 3. It would be nasty fractions, but I could do it. So that means that I need to alter this first one because it's the one that's out of kilter. So I'm going to need to move the 2x to the left side. The 2x is positive, so I need to subtract it from both sides. Does everybody agree with that? So I'm going to get 3x minus 2y equals negative 5. What did I do to get that? I subtracted this 2y from both sides of the equation, and then I wrote it down here because I didn't have room to write it up there. I'm sorry? No, I subtracted this from both sides of the equation. See how it was positive over here? When it moves over to the left, it's negative? Okay. Now, we have a different situation here because neither one of my variables have the same coefficient but opposite signs. Do they? Do they? This one and this one. Here's my two equations. Let me rewrite them. 2x plus y equals 6 and 3x minus 2y equals negative 5. This was my top equation, manipulated, and this is my bottom equation. They don't have the same coefficient but opposite signs. I do see that my y's have opposite signs, so perhaps I can work with that. Now, if you remember a minute ago when I went through the long list of things that teachers call this, one of them was elimination with a by addition with multiplication. I think I said multiplication at some point, didn't I? I did? Okay. So you can multiply the equation by a number to create its coefficient as you want it to be. So I really want this y to have a 2 on it, don't I? I mean, it's positive. This one's negative. I'm halfway there. So I'm going to multiply this equation, the whole thing, by 2. Sometimes you'll have to multiply both equations to get one of the variables to have the same coefficient. When you do that, you're going to get 4x plus 2y equals 12. And you can't forget that you're multiplying it by everything in that top equation. You're going to bring your other equation over. I usually just draw these little arrows just to say, I'm moving it over, but I don't put an equal sign there because that would be confusing. You already have equal signs. So 3x minus 2y equals negative 5. And now we can draw the big plus sign, can't we? So if they have the same coefficient and opposite signs, we can eliminate.
If we need to multiply both equations, do they have to be multiplied by the same number?
No, they would not be multiplied by the same number. Let's say, for instance, we wanted to eliminate the x's in this problem, which I'm not finished with this problem. I haven't stopped. I'm just pausing for a minute. Okay? But if I wanted to eliminate the x's, the only thing I can turn, or let me rephrase this, the least common multiple of 2 and 3 is 6. So I would have to multiply this equation by 3 and this equation by negative 2, right? One of them's got to be negative in order to eliminate by addition. But yes, you may have to do it by the same number. If you have to multiply, not by the same number. You may have to do it to both equations, but it would be a different number if you had to do that. Okay? So let's go over here. 4x plus 3x is 7x. That went away. 12 and negative 5. 12 plus negative 5 is 7. Divide by 7. Divide by 7. X equals 1. You found the x. You have to find the y now. I'm going to put this into whichever one of these equations right here looks the friendliest to me. The top one looks better than the bottom one, so that's the one I'm going to use. I could even go back up here to this one and put it in, okay? Remember, it won't matter because that equation right there is that equation right there, just in a manipulated form, okay? So I'm going to take it and I'm going to put it in right there. I'm sorry, right here's where I'm going to put it. So I will get 2 times x, which is 1, plus y equals 6. 2 plus y equals 6. Subtract 2 from both sides, so y is what? 4. The order pair solution is 1, 4. Okay, let's do another one, if there are no questions on that one. We're good? Okay, let me give you one to try. This will be like the one that we just discussed. You're going to have to multiply both equations by something, okay? (5x minus 4y equals 2, negative 3x plus 7y equals negative 15. Does it matter which variable you choose to eliminate? Some of you might go after the x's. Some of you might go after the y's. They're both already opposite signs, so it actually makes both of them very viable options, doesn't it? Okay? All right, see what you can do with it. All right, so we are back to this problem where we are going to need to multiply both equations by a number. I have two choices. I like that they're both already opposite in sign, okay? So that means that I could turn the 5 and the 3 into a 15 because that's their least common multiple, Or I could turn the 4 and the 7 into a 28 because that's their least common multiple. I like smaller numbers better than larger numbers, so I'm going to go after the x's. Okay? Either way is fine. I'm going to multiply this equation by 3. And I just write times 3. Some students put big parentheses around their whole equation and put a 3. Whatever works for you is fine. I'm going to multiply the bottom equation by 5. And that will take care of turning the, turning the x's into 15s. So I'm going to get 15, 15x minus 12y equals 6, and negative 15x plus 35y equals negative 15 times 5 is 75, right? Okay. The x's cancel, eliminate. Negative 12y plus 35y is positive 23y. And 6 minus 75 is negative 69. Now, I didn't write my giant plus sign on this one, okay? I know that's what I'm doing, and I just stopped doing that. Divide both sides by 23. And you get y equals negative 3. Now, you're going to take that y and you're going to put it back in. I usually go back to the originals because these numbers are big, and like I said, I'd rather work with smaller numbers. So I'm going to go back to whichever one of those looks the easiest. The top one doesn't have any, it only has one negative in it, so I'm going to go with that one. So 5x minus 4 times y, which is negative 3, equals 2. Those numbers are a little smaller as well. 5x. Now you have minus 4 times negative 3. Well, 4 times negative 3 is negative 12, but that's a minus negative 12. So you can also think about that minus in front of that 4 as the sign of it as you multiply it. And so that's going to give you positive 12 equals 2. Subtract 12 from both sides. 5x equals negative 10. And so x equals what? Divide by 5. X equals negative 2. So this order pair solution, make sure you put the x first and the y second. Students miss that a lot. They'll put the y first and the x second, so don't do that. Any questions? Okay. So let's do one more, and then I think we'll actually be finished for the night. Well, there's just tons of examples in your book. Some have decimals, some have fractions, some get fraction answers. I believe this one I'm going to do is going to get fractional answers. These are all positives. I know that I need one of the variables to have a negative on it. I need them, either the c's or the d's to have the same coefficient. So you just choose. What can I turn my c's into? 6. What can I turn my d's into? 20. It's your choice. I'm going to go with 6 because that's smaller. Okay? So I'm going to go after the c's. So I'm going to multiply the top equation by 3. That will turn the 2c into a 6c. 6c plus 12d equals 3. I'm going to turn, I'm going to multiply the bottom equation by 2, but not just 2. I'm going to multiply it by negative 2. So it'll be negative 6c minus 10d equals negative 6. It's going to leave you with 2d equals -3 divided by 2, so D is -3/2. So I got a fraction, okay? That will happen sometimes. You will need to take this and plug it in, substitute it is the proper word, in for D, either in the first equation or the second equation. Here's where you need to do a little thinking before you do it, so that you make your life a little easier. The bottom number is 2. I'm going to be able to cancel it with either the 4 or the 5. Which one when I multiply it? A 4, right? Let's go after that even one. So I'm going to say 2C plus 4 times D, which is -3/2, equals 1. I'm going to cancel the 2 into the 4, goes 2 times. I have a 1 left in the denominator. 2C minus 6 equals 1. Add 6 to both sides of the equation. 2C equals 7. Divide by 2. So C is 7/2. When you have variables that are not x and y, you put them in alphabetical order. So since this is C and D, C will come before D. 7/2 and -3/2. Any questions? All right. We're not going to do the application problems, which are in section 4.4. And I think that's it for this section, for this chapter. So 4.1, 4.2, 4.3. Oh, and we don't cover 4.5, systems and 3 variables either in this class.